By the end of this video, you would be able to code for a fully functional calculator that has all functionalities of a calculator present on the side frame in macOS. We are going to develop a graphical user interface version of calculator using Python 3 and the most famous GUI library tkinter. The final product of the video is being depicted on the screen. tkinter is Python's de facto standard GUI and is included with the standard installs of Python 3. You can access the complete code here on GitHub, which is linked in the description below. We shall discuss the process in three parts which are properly demarcated into sections so that you can grasp more out of this video. In part 1, we will prepare the application's main window and get the app running. In part 2, we will build the calculator skeleton with no functionality. In part 3, we will add the functionality to the calculator app. Aggregating these three parts will allow us to enjoy the calculator app made using Python. Import tkinter module into workspace and math module for using the square root function. Instantiate the tk class that provides us the ability to utilize functionality of tkinter. Set the title of our application window to calculator app. Start the application's main loop waiting for mouse and keyboard events. After running the Python code snippet, you will end up having a window open with the title calculator app. This is how the calculator app's wireframe looks like. The mathematical expressions, numbers or operators clicked by the button should be visible on the answer entry label here. The final answer on click of is equal to button after evaluating the expression would be visible on the answer final label here. AC, all clear button on click clears out the current data and prepares the calculator to start a new calculation. The corresponding row and column numbers have been depicted in the wireframe to have a clear understanding of the placement of buttons and labels in our app. Let us start creating our labels and variables. Let us start with the creation of answer entry label, a string variable that shows expressions on the calculator screen. Let us declare a label for our answer entry label variable. The font we would be following throughout the course would be Futura with text size 25 and text type bold. The text variable to be shown on the label is the answer entry label variable. Let us also add some other attributes for some UI bump. The label would be spanning around 4 columns which we will add in the grid. In the similar way, we will declare the answer final label string variable and also add a label for the same with the text variable to be answer final label. We can hardcode all the buttons, but that doesn't actually prove a software developer's niche towards development. So we are going to dry our code by finding some relationship between the widgets. The buttons in the rows 2, 3, 4, 5 and columns 0, 1, 2, 3 are following a similar pattern of placement of the buttons. We will also create some blank buttons for the last row which follows a similar pattern as the above buttons except the dot button. Let us define a function known as createButton that takes an input of the text to be shown on the button. X and Y are the rows and columns of the grid placement respectively. The font is same that has to be followed throughout the application. Some UI bump. The text to be shown on the button is an explicit conversion of the text input into a string. The command that has to be executed on the click of button is the lambda function of change answer entry label which takes an input of the text shown on the button. The row and column are X and Y respectively. We will be creating a list of buttons that contains the string values of the text to be shown on the buttons in an ordered manner so that we can run a for loop on them easily. We will be creating a variable named buttons list traversal counter which we will be using to traverse across the buttons list and will initialize it to 0. The outer for loop is for iterating across the rows and the inner for loop is for iterating across the columns. The values of I and j give the corresponding values of x and y that are to be inputted into the create button function. The txt would be the buttons of buttons list traversal counter. The buttons list traversal counter would be incremented by 1 every time we iterate through a loop. By this, we can traverse across the whole loop. We will hardcode all the other buttons because either they have different commands or have different placements in the grid. we will be adding the AC button that has a command called all clear. We will be adding the square root button that has a command called evaluate square root. We will also be adding the 0 button whose command is only changed as entry to 0, and we will also be adding the equal to button that has a command called evaluate answer. To store the expression we are entering with the help of buttons that should also be printed on the answer entry label is stored in a global string variable named answer variable global. Let us also create another global string variable known as answer label for square root, whose use will be discussed later. Let us create the function change answer entry label that appends the entry by buttons to the answer entry label on the click. We shall append the entry by explicitly converting it into a string. We will also copy the answer entry variable global to answer entry label for square root for future use. After appending to the answer variable global, we will show it on the answer entry label on the screen. Let us define another function allClear that works on the click of AC button. This function onCall should clear out all the data and prepare the calculator for new calculation. All the variables and labels are set to empty strings on call of this function. Let us create the main function evaluate answer that evaluates the expression present in the answer variable global and then returns a value to answer final label. Also clearing the answer entry label using clear answer entry label function that we have created earlier. We are also handling the error if the expression contains any value like syntax error or type error, zero division error by printing an error message to the answer final label. Let us create another function evaluate square root that evaluates the expression present in the answer label for square root of value and then returns that value to the answer final label. If the first type fails, we are also handling the error by trying for an alternative route by calculating square root of answer variable global, and if even that route fails, we tend to print out the error message onto the screen. On running the script we have written just now, a calculator app is open in front of us. A GUI version of the calculator that looks brilliantly amazing is in front of us. We can evaluate expressions like 12 plus 3 gives 15. We can also find the square root of 8 or square root of 5 plus 2 minus 2 plus 3, which is actually the square root of 8. When we click the AC button, the whole screen is cleared or the calculator is ready for new calculations. We can also calculate the float like 3.2 plus 5.2 gives 8.4, and if there's any error in the expressions, an error message is to be depicted like 12 divided by 9 into 3 plus. This should give us an error, and also 7 star 6, that's 7 into 6 plus square root. This should also give us an error because these are invalid expressions. A very detailed blog on how to code for this mini project is on Medium, whose link is given in the description. Looks easy, isn't it? This is how you can develop a mini project using Python 3. Stay tuned to codestudio.saiankit for many more interesting stuff on software development. Signing off, Saiankit.